because that way you'll know what you do and don't understand. Okay, so we have these two functions. We have f of x, we have g of x. So f plus g of x means that I'm taking f of x plus g of x. That's what that means. So I'm going to take the 2x plus 3 and add that to the negative x minus 8. So when you combine your like terms, I'm adding these together, and I'm going to add these together. So the answer, the correct answer that I'm looking for on the skills check tomorrow and your quiz next week would be x minus 5. That is the answer. For part B, it says f minus g of 2. So what that's asking us to do is figure out what f of 2 is and then subtract g of 2. So f of 2 is 2 times 2 plus 3, which is 7. G of 2 is negative 2 minus 8, which is negative 10. And when I subtract, I get 7 minus negative 10, which is 17. All right, who had number 1 right? Any questions? All right, part 2, we have to do a substitution. And I'm substituting in x minus 2, both places where I have an x. So the first thing you should have is 2. And I like to make my little shell. And I have to put that x minus 2 in both places. Now, hopefully nobody makes this mistake, but I know there's going to be at least 25 out of my 90 that will. X minus 2 squared, you can't just do that and say that it's x squared plus 4. That is wrong, okay? You have to multiply that out fully. And I don't care which way you do it. You don't have to make a box. You can FOIL, you can use the distributive property, but you need to multiply x minus 2 times x minus 2. If you do it correctly, I'm not going to show my steps, but you would get x squared minus 4x plus 4. And then this is x minus 2. All right, so now I'm going to distribute the 2. This is a positive 7. So I get 2x squared minus 8x plus 8 plus 7x minus 14. And my last step is to combine my like terms. So these are going to be added, and these will be added. So your final answer is 2x squared minus x minus 6. Just curious, did anybody get all 3 of those right? Oof, nobody? Well, what did we miss the most? Last one, what part was it? The multiplying? The x minus 2 times x minus 2 part? Okay. I can assure you, it's not a maybe. This is a fact. You will have that on the skills check tomorrow. It's on the quiz, and it's on the test. So do we understand how to do that? Is there anything you need me to re-explain? All right, so that's the end of 2.2. So now let's talk about 2.3. So I did make a change, and I haven't made it on Canvas yet, but I will. The due date for homework 8, I pushed it back. And I changed it on the board, but I will change it on Canvas. I'll try my best to remember to change it. But I'm pushing that to Tuesday, September 2nd. So you still have homework 7 due tomorrow. Okay. And homework 8, I pushed to Tuesday. Now, I am going to change my 1-day grace thing with the homework, but we'll talk about that later. But I feel like that 1-day grace is not really fair to the people who turn it in. You put it on my desk. To the people who turn it in on time. So I am going to modify that starting with homework 9. And we'll talk about that next week. Alrighty. So if you're titling your notes, we're starting 2.3, which is properties of functions. Properties of functions. Now, go ahead and copy this down. I'm going to change this a little bit. You don't have to. So take a minute. We're going to talk about even versus odd. If you remember, this was the question on the last review. I told you to cross out number 14. This is now that content. So it's on this one. So we're going to talk about even versus odd functions. So even simply means that you have y-axis symmetry. And odd is origin symmetry. And we'll talk about how to figure out what that means with an equation and also how to figure that out using a graph. So I'll give you a moment to copy that down.
Are these notes on Canvas?
No. I record it and post it to Canvas.
You got jar graphs too.
I mean, I'm just going to make a little sketch. I mean, it don't have to be perfect. So if something is even, that simply means that it has symmetry with a y-axis. So what that means is that the left side, if you were to draw a graph, I'm just going to make a sketch. And you don't have to make points. I'm just doing extra, really. Trying to make it match up. Whatever is happening on the left side of the y-axis is happening on the right side of the y-axis. That's what y-axis symmetry looks like. It's like a parabola. There's other things that can have y-axis symmetry, but the easiest one to think about is a parabola. If it has origin symmetry, that means that if you rotate it 180 degrees, it's the same. So the most basic one to draw would be like a cubic function. And we are going to graph. Starting next Friday, we do a lot of graphing. So hopefully you have graph paper. If not, I did get a donation. I have some. So in order to determine if a function has even symmetry or odd symmetry, we're going to do the same thing, which is replace x with negative x and then simplify it. Okay. So let's talk about example 1. Example 1 is even, odd, or neither. So just copy down A. We'll work through A together. And then we'll work through B and then C. So looking at the equation, we want to determine if this function has even symmetry, odd, which is origin symmetry, or no symmetry. And when we do that, all we're going to do is replace. I'm just going to replace the x with negative x. That's what I'm doing. I'm going to take my x and replace it with negative x and then simplify it. So I'm going to look at my x's, so these two. So I have f, I'm going to rewrite it to, okay. And then inside of the parentheses, I'm going to put a negative x. Now the hardest part, because inside of this parentheses, when you put a negative x, that's really two things. Negative x is really -1 and positive x. So this is what you need to figure out, okay? You need to figure out if -1 to the power of 5 is equal to a +1 or a -1. That's my only two options. So don't say it out loud. But what do you think -1 to the power of 5 will give you? Do you think it's going to be positive or negative? So who says positive? Who says negative? Oh, good. Amen. Thank you. Yes, it's negative. So because this stays negative, that's going to make the 2 become negative. So that's going to become a negative 2x to the 5th. Well, that's a good question. I was going to tell you all the rule, but then I thought, well, I don't want to tell you the rule. How do we know when it's going to be positive or negative? What kind of exponents will make it positive? Even exponents. Even exponents will make it positive, but odd exponents will stay negative. So then this is going to become a positive 3x. So when you compare these two equations, when you compare this equation to this equation, what do you notice about the signs? So you see how this was a +2? What did it change to? A -2. And then do you see how this -3 changed to a +3? Because the equation is completely opposite, that means that this has odd symmetry. It has to be completely opposite. It can't be half opposite, it has to be completely. So this graph has 180 degree. If you rotate it 180 degrees, it's going to look the same. All right, let's go ahead and check the next one. Now this one has all even exponents because 4 and 2 are even, which means that the negative ones will become what? Positive. So because it becomes positive, it's kind of like saying that the negative just cancels out. That's really what's going to happen. So we get 3x to the 4th plus x plus 2, which, if you look at it, is completely the same.
I have to put the square on top of it.
We do, thank you. Completely the same, which tells me that this has even symmetry. So if it's completely the same, it's even. If it's completely opposite, it's odd. And we could probably, you probably already know that the last one is going to be neither. And you do have to show me this step. Even if you can look at it, like I can look at it and I know odd, even, neither, you still have to show me some steps when you do it on the quiz. So we have F. Go ahead and set it up. And I have my negative x. So I have f to the negative x. This one is going to stay positive, but my second one is going to switch from a positive to a negative. So if you compare the new with the old, it's not opposite, it's not the same, it's neither. So this has no symmetry. All right, so you should have 3 cutouts. We're going to do example 2. Now, I have realized that some of you all are like very particular in your gluing, okay? It takes us a lot of time to glue things. So what I did was I borrowed a basket of scissors, okay? We're going to do all 3 of these graphs. Now, what my thought was is that you would just glue it down. You don't have to write this down. My thought was you would just glue it down and you would write under it. But my second period said no. They wanted to cut theirs apart and put them vertically. I don't really care how you do it. I'm going to give you a couple minutes to get them glued down. But before you start doing that, now this slide, in my opinion, you don't need to write this down because we already know this. We know that if something is increasing, it's getting larger, right? Do we know that? And we know that if something is decreasing, it's getting smaller, right? And we know if something is constant, it's going to stay the same. So what we're going to do with these next 3 graphs is we're going to write increasing, decreasing, constant. So you can glue them down whichever way you want to. So I'm going to give you a few minutes to get those glued down. Just example 2. Feel free to borrow some scissors and all of that because I know some of you are really type A people. They have to be a certain way. That's okay. I'm a type B person. Me too. That's what I do. I'm just that's the thing. Some people do a lot. That's okay. We all have our different icks. So I'm gonna give y'all some time. Hopefully this don't take like 20 minutes. I'm gonna give y'all like 2 minutes. Okay, you ready? All right, so let's talk about it. So we're gonna talk about increasing and decreasing interval, okay? Increasing, decreasing, and constant interval. So one of the main things that students will get confused when you see this on the quiz next week is that when I'm talking about increasing and decreasing, I'm only talking about the domain. This is what we're focusing on, which is your x values. You should not look at your y-axis for increasing and decreasing. So that's the first thing. The second thing is, whenever you're reading a graph, you read it from left to right. So you're going to trace starting from the left side going to the right. You never trace from the right to the left. Just like I don't read this like this. I don't read it from the right to the left. You're going to read the graph from left to right. So let's go ahead and add arrows because I forgot to. Well, yours may have it. I might have added it before I made copies. I don't know. But add them. All right. The left side. The left arrow will always be negative infinity. The right arrow is positive infinity. Because the left side, x is negative. And on the right side, x is positive. So looking at the screen, I want you to look at this red dot. I'm tracing the graph. What is the red dot doing? Is it going up or down? Up, which means that this is increasing, and it started to increase from negative infinity. So let's look at the board again. I'm tracing it. See, negative infinity, the dot is going up. It stops increasing right here. What does x equal right there? 0. Now, you don't put 4 because we don't care about the y-axis. It's the domain. So from negative infinity to 0, this graph is increasing. So I'm going to highlight it from here to here. This is going up. Then, starting at 0, it goes down. When does it stop going down? When x is what? 2. So from 0 to 2, it decreases. And then starting at the 2, It increases and it stops at infinity. It never stops. So this graph had 2 increasing intervals, 1 decreasing interval, and no constant interval. That is it. You're going to read it from left to right. Left to right. Any questions? Ayomide, you okay? You don't look like it. You might need to stand up or something. All right, so now let's look at our next graph. So go ahead and add the arrows if you haven't already. So again, this is negative infinity because that's the left arrow. This is positive infinity because that's the right arrow. So when I'm tracing it coming in from negative infinity, what is happening to the y value right here? It's constant. Would you agree when you look at my red dot that it's not going up or down, it's just straight? So that means that from negative infinity until x equals what? What does x equal when it stops being constant? Negative infinity to -5 is constant. And then what does it start doing at -5? Does it start to go down or does it start to go up? Down. So starting at -5, ending here is decreasing. And it's decreasing from -5 What does x equal right here though? 0. So you would say -5 to 0. Then starting at the 0, from 0 until the top of the hill, what is the x value at the top of this hill? 6. So from 0 to 6, it increased. And then starting at 6, it decreased. And it decreased from 6 to infinity. So this graph had 1 increase interval, 2 decrease intervals, and 1 constant interval. Who remembers this from Algebra 2? Because this is Algebra 2. Okay. Like I was telling somebody, one of my, like this is really just Algebra 2. Pre-calc the first semester, it's Algebra 2. Super fast. We do the whole year in the semester. All right, last one. Now, even though both arrows are pointing up, that does not matter. The left arrow, negative infinity. The right arrow, positive infinity. So let's start tracing it. So look at the screen. What is my red dot doing? It's going down. So this is going to decrease from negative infinity until we get to here. And what does x equal right there? 1. It decreases from negative infinity to positive 1. And then starting at the 1, it goes up. And it goes up between x is 1 and y is 3. So from 1 to 3, between, and that little piece of the domain is increasing. And then starting at 3, it starts to go down again. Now, what would you write for your decreasing interval?
3 to 4.
3 to 4. And then starting at 4, 4 to infinity is going up again. Was this graph ever constant? No. All right, so what I want you to do, this is actually the end of the class, but what I want you to do, so we're ready for tomorrow, we don't have to waste time. Go ahead and get your example 3 copied down, okay? We're gonna write 4 things about each one of those graphs. Now we're gonna talk about this tomorrow though. Okay, so I'm gonna give you some time. The rest of class, you can go to a new page, whatever you gotta do. Glue down those 4 graphs that you all have. Use your little scissors and all of that. So that it's ready to go for tomorrow.